Let's suppose that we have 4 teams and each team needs to be assigned a project. So in this case, we're assigning work to limited resources. This is a process called loading. You can see here on our screen, we have 4 teams, crew 1, 2, 3, and 4, and they have 4 houses that need to be completed. The top table shows the number of hours it would take each team to complete the project. So for example, if crew 1 were to work on house 1, it would take them 20 hours. If crew 1 worked on house 2, it would take 90 hours. It takes different amount of time to complete the project depending on the project, so which house, as well as the expertise of the team. So for example, crew 4, if they worked on house 1, it would take them 60 hours, whereas if crew 2 worked on house 1, it would take them 40 hours. Now we can do the loading process manually by using row and column reduction methods. Or we can use linear programming and the solver add-in to do it for us. To make sure you have the solver add-in, go to the Data tab, and in your ribbon, you should see on the far right what is called Solver. If you do not have the solver appearing here on the right, you need to add it in. It can be added in by going to File and Options and Add-ins, and at the bottom you'll see where it says Manage Excel Add-ins. Click on Go and make sure the solver add-in is checked in your box. When you hit OK, under the data ribbon, we should now see solver in the right. The other thing we need to do to prepare our task is we need to create 2 tables that are right now filled with zeros. These tables are what is going to be filled by the solver add-in. The first table, for each combination of crew and house, we have just typed in 0. These are the placeholders that the solver is going to fill in. The other zeros that you see on the screen are based on formulas, so let's make sure those formulas are entered in. We want to make sure that when we load these activities to the different teams, only one activity is allocated to each team. To do this, we need to do equals sum and add up houses 1, 2, 3, and 4 for crew 1. We're going to set the solver to make sure that the total of this row only equals 1. That is, crew 1 only gets 1 project. So we repeat this for each crew. Equals sum, highlight houses 1, 2, 3, 4, and for now it's equaling 0, but we're going to set the solver to make it equal to 1. Repeat that for crew 3 and for crew 4. Now, just like we want each team to only have 1 project, we also want 1 project per team. So for house 1, we type in equals sum, and we need the 4 crews to be added up, and with solver, we're going to make sure this total is equal to 1. So 1 crew is assigned to 1 house. Same thing for house 2, equals sum, highlight crews 1 through 4, and get your totals. You repeat this for house 3 and for house 4. Now, once it's allocated the work, we need to know what the cost of those activities are. So this third table that you see here is going to total up for us the cost of each crew and the project they're working on. So to do this, for house 1, crew 1, we're going to take the number of hours that it takes for house 1 to be worked on by crew 1 times whether or not house 1 is done by crew 1 times the cost per hour, which is $60 in this example. And we would repeat that. So for crew 2 to work on house 1, it would take 40 hours times whether or not crew 2 works on house 1 times the $60 an hour. And you would do that for all combinations of the 4 houses and the 4 teams. Before we can start the solver, we have 5 more formulas to type in. We need the total cost for house 1 to be added up. So equals sum, and then the total cost of the 4 teams with house 1. And we would do the same thing for house 2, equals sum, and the total of the 4 teams. And you do the same thing for house 3 and house 4. Ultimately, we want to allocate these crews to the different projects in order to minimize overall cost. So we need to make sure that we have a formula that totals up all the cost for all 4 teams working on all 4 houses. So we have equal sum, and we're simply adding up the costs for the 4 houses. All right, now we're ready to do this in Solver. So we go to our data ribbon, we click on the solver function, and we need to set an objective. Our objective is the total cost, and we want it to be as low as possible, so minimum. And we're going to do that by changing the cells. We see where we have our zeros for crews and houses. We're going to change those so that we can assign the tasks. So we're going to change the variable cells J9 to M12. Now we're going to select a solving method, and we're going to use the simplex linear programming. We are going to make sure that we make unconstrained variables non-negative, so we can't assign a house to a crew with a negative number. So right now we only want zeros and ones. 0 if it does not get the assignment, 1 if it does. So we don't want Solver throwing in negative numbers. To add in our constraints, you'll recall that we only want to assign 1 house per team and 1 team per house. So for our constraints, we want to add them in, and we want to make sure that our row totals, so N9 to N12, we need them to each equal 1. So let's add that. We need our column totals, so the sum for each house, we need each one of those to equal 1. This will ensure that we have 1 house per team. The other thing that we need to add, let's try that again. Make that equal to 1. Okay. You can always hit OK and see your list of constraints. So here we have 1 too many, so let's delete the one that appeared. So we have here the total of our columns, so that's the J13 to M13, and we have the total of our rows, that's the N9 to N12, and each one is equal to 1. This makes sure when we're done, all 4 columns and all 4 rows will have a total each equal to 1. The last step in the process is to make sure that when it fills in our houses and our teams, that it only fills in zeros or ones. So what we want to do is we want to add one more constraint that goes from J9 to M12, and we want to say these must be integers. Okay, so let's hit OK, and we now have 3 constraints. Then all you have to do is hit solve, and we can keep the solver. And so what you see that it's done is it has allocated house 4 to crew 1. It has allocated house 1 to crew 2. It has allocated house 3 to crew 3, and house 2 has gone to crew 4. So we set that it had to have these rows equal to 1 and these columns equal to 1, and it has done that. It has also determined that the total cost of all 4 projects will be $7,800. House 1 done by crew 2 costs $2,400. House 2 done by crew 4 costs $2,700, and so on. And so we have assigned the work to the different teams, and minimized our costs by doing so.